Today we're going to talk about multiple representations of inverse variation. So let's write our title. And if you don't have space on the top line, continue writing on the second line. When we say multiple representations, we're talking about the different ways that you can represent an equation. So you have an equation, graph, table, or a verbal description. Let's look at an inverse variation equation. Inverse variation equations are written in the form of y equals k over x. And k is actually going to be a number every time. K, whatever number it is called the constant of variation. So whenever we see an equation that's y equals 3 over x, or y equals 17 over x, y equals negative 5 over x, that's an inverse variation equation. Y equals some number over x, and the number over x is called the constant of variation. So for our first example, you're going to be given an equation. And we'll talk about the different ways to rewrite that equation. So the equation that you're given is y equals 8 over x. And based off of that given information, we can write a table. Remember, we used to write tables with x and y values. And I'm going to give you a few numbers to fill in here. X value is negative 4, the x value is negative 2, if the x value is 0, and then on the right, what if the y value is 32, and what if the y value is 1? Let's figure out what else goes in this table together. So, using some of your old skills, we know the equation is y equals 8 over x. So, if I want to find out what y value goes here, I set up the equation y equals 8 over x, and x is negative 4 in this case. So 8 divided by negative 4 is negative 2. So we know negative 2 goes here. And we'll go down the lines with the other ones to figure it out. We're given x is negative 2, so we'll say 8 divided by negative 2. 8 divided by negative 2 is a negative 4, so we know that negative 4 goes here. What about when x equals 0? We'll have 8 divided by 0. We can't divide by 0. That's undefined. And you'll find that every time we have an inverse variation equation, x cannot be 0. So I'm just going to write a dash here. It does not exist. X is undefined right there. Now let's try the last two parts of the table. We're given our y value. So instead of saying y equals 8 over x, I'm going to say 32 equals 8 over x. And if I want to solve for x, one way to think about it is I multiply x times both sides of the equation so that I can get rid of that fraction and cancel out. And x times 32 equals 32x. And the x is canceled out, so I just have 8 over here. Now to get the x by itself, I'm going to divide by 32 on both sides so that I have x is equal to 8 over 32, or if you reduce that fraction, you can write it as 1/4 or 0.25. I'm just going to write 0.25 here. And our last one, when y equals 1, 1 equals 8 over x. And I can multiply by x, or another way to do this is to say, to find out what x is, we would complete 8 divided by 1. So basically, we switch this number with this variable that's down here. So 8 over 1 is just 8. X equals 8 in this case, and we filled in our table. So we have two ways to represent that equation. We have the equation and we have the table. Another way to write it would be a written description or a verbal description. So our verbal description might say something similar to, we have a graph, we have an equation and we have a table. Our verbal description might say something similar to, y varies inversely as x with a constant, or it might say a constant of variation with a constant of 8. That's our verbal description. For the graph, I'm going to use Desmos.com. Remember, our equation is y equals 8 over x, so I'll type in 8 slash x. And we have a graph here. Looking at the graph, you see there are two parts. And if I zoom out a bit, you see that the graph gets closer and closer to this x-axis over here, and the graph gets closer and closer to the y-axis this way. And on the bottom part of the graph, it gets closer and closer to the y-axis here, and it gets closer and closer to the x-axis here. This shape has two separate parts that actually don't touch these axes. They don't touch the x-axis or the y-axis. So just a representation of my graph, I might draw my x and y here. And the graph is going to look the same unless you have graph paper, but the graph is going to be this shape called the hyperbola, where we have one piece or one branch right here and another branch right there. So that's our graph, and it is called a hyperbola. Now let's try another example. For our first example, we were given the equation. For our second example, I'm going to give you a verbal description. The verbal description is the time to drive from work varies, or the time to drive home from work. The time to drive home from work varies inversely to the speed of the car. By a constant of 250. So this time we have a little bit of a word problem here. When we say something varies inversely, I know that my equation is going to be y equals k over x. I just need to find out what the constant of variation is. So the constant of variation is given to us, so I know that the equation for this problem is y equals 250 over x. So now we have a verbal description and we have our equation. So let's make a table. And again, I'm going to give you part of the table. X and Y. And we'll just have a short table here. Since we're talking about the speed of a car, we're not going to have negative numbers here. And let's just fill in the missing values. Now notice for inverse variation, as my x values get bigger, as we go down the line and the x values get bigger, my y values are getting smaller. And every time my y values get bigger, my x values get smaller. And that's what we mean by inverse variation. One variable gets bigger and the other gets smaller. Or one variable gets smaller and the other gets bigger. Let's go to Desmos for our graph. This is, and as you can see, it looks similar, but when we zoom out, we can see that the graph is actually a lot farther from the middle, from the origin here. The graph is actually a lot farther from the x and y axes here. So let's draw our graph on paper to the best of our ability. The graph, draw my x and y axes, and this time it's a lot farther from the middle here. So I draw my piece there, and another branch over here that's farther from the middle than the last one. And that's our graph. Let's do one more example. So you've been given the equation and you've been given the verbal description. Now for our last example, we want to start with the table. And we're going to find the equation, the verbal description, and the graph from the table. So you're given a table. And the values are already filled in. -2, -1, 0, 1, 2, 4, 8. And the y values you're given are -8, -16, no value right here, +16, +8, +4, +2. So you have a table and you're not sure how you can figure out what the equation is. We know that it's an inverse variation equation. It's given in the problem. So we know that inverse variation has this format, y equals k over x. We just don't know what is k in this case. So to figure that out, what I can do is take a couple of numbers from this table and figure it out. So let's substitute the -2 for x and the 8 for y, or the -8 for y. -8 equals k over -2, and we can use this to figure out what is k. So to get k by itself, we need to get rid of that fraction. And to get rid of the fraction, always multiply by what's in the denominator. Let's multiply by a -2 on both sides of the equation. -2 times -8 is 16. So k is 16. I can think of it that way, or I can look at the table and say -2 times -8 is 16. -1 times -16 is 16. 1 times 16 is 16. 2 times 8 is 16. If you'll notice, for inverse variation, when we multiply x and y together, we get k. So from our table, we multiply x and y together, and that will give us k. So if we know our k is 16, here is our equation. We have a table, and now the equation for our function is y equals 16 over x. We can write a verbal description and say y varies inversely as x with a constant of variation, or just a constant, of 16. And for our graph, we would go back to Desmos, 16 over x. And it looks very similar to our first graph. The hyperbola is really hugging that x-axis and the y-axis. So let's draw our graph. Hyperbola, that's one branch of the hyperbola. And here's my second branch that's really hugging that line. And we are done.